Alright, this one's a little tricky. This is the, well, let's see, what do we have? We have a 2.5 kilogram object. It has a moment of inertia around the axis of rotation, which they label at right here, of some number. The rotation axis is horizontal. When released, what will be the object's initial angular acceleration? I am going to say it's going to be our torque divided by moment of inertia. Now my torque is caused by gravity at this point right here, and I'm going to draw this freakishly too big. It's my weight. It's the weight of the object, which up here 2.5 times 9.8. I think that should be 24.5 newtons. You should know right now by now how to get weight. But it hits this axis of rotation at a straight line down, and I need to find my radius, which is going to get a little crowded in here. The radius is that dotted line of that triangle. The 17 is the hypotenuse. So I need to find the radius with SOHCAHTOA. The angle's 25, it's adjacent, so it's cosine of 25 equals adjacent, which is that dotted line, divided by hypotenuse, which is 0.17 meters. 0.17 meters multiplied by the cosine of 25 equals adjacent, and I believe this comes out to be 0.15 meters. That's the adjacent. So my torque is, I'm running out of room here. I'm going to box that off. Torque equals force times radius. My force is the weight. I just did that up here. And it's applied on the radius, which is this straight line which I labeled earlier, and I just calculated out to be 0.15 meters. And I get a torque of, let's see, 24.5 multiplied by 0.15. I believe that's about 3.77 Newton meters. So I'm going to come over here. My torque is 3.77 Newton times meter. And moment of inertia was given of 0.085 kg times m squared. Throw that in your calculator, and you are going to get 44.4 radians per second squared, because I was looking for acceleration, angular acceleration. And since it's going clockwise, that has to be negative. Woo woo? Woo woo.